Hello everyone, welcome back to another video. I'm here with my wonderful cat, Mr. Casper, and we're here to talk about how a 24-hour EEG broke my software. It completely destroyed my computer program. So I've been trying to make EEG software, and I've only been testing it on routine EEGs that are about 30 minutes long, because I didn't have any long-term EEGs to test it on. So my brother and I, we just stitched together a bunch of 30-minute EEGs. So we'll have something that's 24 hours so we can load it into the program and test it. So when we did that, it completely crashed our computer. So we had to do some calculations. We had to calculate how much memory is being used on the computer to load this computer program that we have. And after looking at the sampling rate and how many bytes the computer is using, it came out to be about using 48 gigabytes of RAM memory to load our EEG, a 24-hour EEG. And most computers have a lot less than that. They probably have around 16 gigabytes, and it took 48 gigabytes if you wanted to load our 24-hour EEG with the artifact reduction technology. And that's how it is right now. It completely crashes our computer, but I think with some clever programming techniques, for example, so when you play these huge open world video games, they're in such good graphical detail, you know it costs a lot of memory to load such amazing visuals on the video games. So what a trick that these open world video games use is they don't load the entire open world game all at once. They only load the part of the video game that the player can see. So it doesn't load the whole entire world, which would completely crash the Xbox or the PS4. They just load the part that the character can see at the moment. So that's one thing that we were thinking of, maybe just loading parts of the EEG that are going to be visible to the reader, the doctor, or the EEG tech, and instead of loading the whole entire thing all at once, costing 48 gigabytes of RAM, which pretty much no basic computers have. But if you wanted to upgrade like a gaming computer or something like that, it's possible to have more RAM than that, but I would have to go through and upgrade every hospital's computer. So better than that, I think we're just going to try and use some clever programming techniques so we don't have to load the entire data all at once, and we can still, get this best performance with the artifact reduction technology and everything like that, because that's what's causing this need for increased computing power, which makes sense of why this wasn't a thing in the past. Artifact reduction, it's kind of like a new thing, because computers weren't good enough back in the day, but now that we have all this advancement in computer technology, all these big companies investing in making better graphics cards, better computers, these big companies are investing billions of dollars into that, creating better computers. So we're just going to get the benefit of that here in our field of EEG. So if we're unable to come up with some clever programming tricks to allow every hospital that has pretty much around 16 gigabytes of RAM to run our high-powered new EEG software, a backup plan would be to upgrade all of these hospitals' computers. You can buy these little sticks of RAM that you can install into the computers themselves, and that would also be another way to allow these hospitals' computers to be able to run our high-powered software named Ion. I just want to thank everyone who's working on better computer chips, better computers, because that all transfers into my field of EEG technology, and it allows us to use the best software possible. Run the best software, because you need good hardware, because this memory stuff, this is the hardware that allows the software to run in the first place. And now that these machines are getting better and better, new opportunities are available, such as this artifact reduction thing to remove noise on the EEG, remove muscle contamination, remove eye blinks, remove just movement and general artifacts that pop up on the EEG, so you just have the clear brainwaves for the doctor to see and make the best reading of the EEG and diagnosis so they can best treat the patient. So that's pretty much it, guys. Make sure you hit the like button if you like this video. I appreciate you guys, and I'm excited to see if we can overcome this challenge of running 24-hour EEGs, because our EEG trending software is primarily used on 24-hour EEGs. It's not really used on 30-minute EEGs because you're looking for the trends over a long period of time. If it's just 30 minutes, you can easily just look at the brain waves. But if you're looking at 24-hour EEGs, you want to look at the brain waves and the trends of the brain data printed out in color form on a spectrogram. I'm gonna end it right there, guys. I don't want to get too in-depth, but pretty much our computer broke because our software uses too much power on the computer, so we either got to upgrade the computer or find some clever programming tricks to get around it. So we'll see what happens, guys. We'll see. I'm day to day. Me and my cat Casper, he's like our mascot, our company mascot. Love to have him here, man. And I'll see you guys on the next video.